When we measure the volume of a three-dimensional shape, we are finding the number of cubes, such as in cubic inches, cubic centimeters, or cubic feet, and so on. How many will fit into the shape without any gaps? A common formula for finding the volume of a rectangular prism is volume is equal to length times width times height. So the volume of the rectangular prism shown in the diagram can be found by 3 by 2 by 4, which is 24 cubic units. This is an easy formula to use, but why does it make sense? Study the diagram below and then answer the questions that follow. So if we have this rectangular prism, what we can do is kind of slice off the cubes. So there's the top layer and the second layer and the third layer and the fourth layer. Well, we can see that each layer would have 6 cubes. So there's 4 groups of these layers. So there'd be 4 groups with 6 cubes in each group. So the volume would be 4 times 6 cubic units. So how did we get 6? Well, the number of cubes in each layer is the area of the base, which is length times width. And then the height is the number of layers. So why don't you take a look at problems 3 and 4 and then come on back. Okay, welcome back. I hope you've had time to take a look at these 2 problems. So first of all, number 3, you can describe how to find the volume in any way that makes sense to you. But what I came up with was the formula makes sense because it first finds the number of cubes in one layer, which is the length times width, which is also the area of the base. Then it multiplies by the number of layers, which would be the height. So volume is equal to length times width times height. Okay, number 4 wants us to find the volume of the rectangular prism that we constructed in question 1. And so volume is length times width times height. So 4 times 7 times 3, which is 84 cubic centimeters, or those little cubes that are 1 centimeter by 1 centimeter by 1 centimeter big. Okay, let's take a look at problem 5, which says, use your general formula for the area of the prism to find the volume of the triangular prism. So a triangular prism looks something like this, but this one has a right angle. This one doesn't. So this is just to give you an idea. Be careful when determining the base. And so we have this triangle that's 6 centimeters by 8 centimeters, and then the diagonal line is 10 centimeters. And then the length of the lateral face is 12 centimeters. And so we want to find the area of the base, which in the rectangular prism was length times width, but with the triangular prism, the area of the base is something different. So what's the area of a triangle? And then, so you'd have the area of the base and then times the height. And so it's laying on its side in the picture instead of the triangles being top and bottom. So the height would actually end up being this length here. So why don't you give that a try? And while we're at it, go ahead and sketch the net for this triangular prism and find its surface area. Let's take a look at problem 5. So the volume of this would be the area of the base, but this is a triangular prism, so the base would be a triangle. So we would use the formula 1/2 the base times the height, and then times the height. Well, this is the height of the prism, which would be 12. So 1/2 the base, which would be 8, times the height of the triangular base is 6. So half of 8 is 4. 4 times 6 is 24, times 12 is 288 cubic centimeters. Okay, number 6 wants you to draw a net. Okay, well, my graph paper isn't big enough because these numbers are fairly big, but our base was 8 by 6, and then this would be 10, and this is the right angle that they have there. And so they said that the prism was 12 long, so then I would have a lateral face that's 6 by 12, which would give us an area of 72. And then if we go up, like this, when this side folds up, this side would fold against this side. And so we would have 10 by 12, which is 120. And I know that goes off my paper. But then also down here, this is 8, and this would fold up to line up against this edge. And so this is 8, this would have to be 8 by 12 is 96. And then on the other side, we have to have the other base. So if this folds up, this would be 6. And then when it folds up, this would be 8 and 8. And then this would be 10 and 10. Okay, so that's what the net would look like, especially if I could add 5 more rows of dots. But then it asked for us to find the surface area. And so the area here was 120 and 72 and 96. And then half the base times the height is 24 and 24. And so when I added those all up, I got 366 cubic centimeters. Let's look at another problem using that same formula where volume is equal to the area of the base times the height of the prism. Okay, just to be sure, this is the formula for the volume of a prism. Okay, so area of the base. Well, this happens to be a prism. Doesn't really look like it, but the base is this kind of U-shaped figure, and then the length or the height is like how deep it is. So the base is the U, so we need to find the area of the base. Well, we can do that a couple different ways. We could split the U into 3 rectangles, or what we could do is find the area of the big rectangle and subtract the little one. So let's do that because it'll be a little bit shorter. So the area of the big rectangle, like if we were to fill that middle gap in, so that would be 10 by 14, so 140 square centimeters. But then we're missing this gap, which is 6 by 6. So I'm going to subtract 36. So I have 104 square centimeters. So that's the area of the base, and then times the height, which is 5, because it's laying on its side. And so our volume would be 520 of those little cubes, the cubic centimeters. So 520 cubic centimeters. Okay, let's look at one more type of problem.